Nonsense will result from the huge number of parameters being optimized in the very large models, overfitting the data.
You're watching the Spotlight Network, starring Hollywood's newsman, Logan Crawford.
They now believe a single member.
He works with TV and film legends. And now, Logan's shining the spotlight on the world's top emerging authors and creators.
International were abducted.
This is Spotlight with Logan Crawford, streaming on Roku, Apple TV, and Amazon Fire TV.
I'm Logan Crawford, and right now on Spotlight, we're talking with William Meisel about his amazing book. It is called Computing Power Drives the Future. It is a timely look at exponential computing growth and what it really means for society and the global economy. The book argues that computing hit a major threshold when it made deep neural networks economically feasible, fueling massive AI investment and ever larger data centers. But it also challenges the assumptions that behind that spending and makes the case that generative AI dominating the headlines is overrated. We're delighted to have this very talented author join us here today, and we ask viewers like you to support authors like him by subscribing to our channel and by purchasing his amazing book. The links are below this interview. William, thank you so much for joining me here today.
Thank you, Logan.
Great to have you on the show. Let's start out by defining one of your key terms, of course, computing power. What do you mean by it?
Well, computing power is the total amount of digital computation available for use at a given time based on the hardware available at the time to deliver that computing. The most obvious source of computing power is the huge computer centers with their racks of digital processors. But each smartphone is also a small computer, and the computing it does reduces the amount has to be done in the so-called cloud, the computing centers reached over the internet. And of course, almost all consumer devices include a microprocessor, from microwave ovens to television sets. Computing power is a major driver of the economy, as critical as oil is today. The importance of computing power is exemplified by the constantly increasing demand for the chips that power it, such as NVIDIA's graphical processing units.
Amazing, amazing. I think that this phone here is probably more powerful than most NASA computers back in the day, early on, that took up an entire room. Talk to us about how computing power is evolving.
The growth in computer power has been typically related to the number of transistors you can fit on an integrated circuit chip. That growth is typically cited as Moore's law, that the number of transistors that can be put on a chip doubles about every 2 years. Another way of thinking about this is that the cost of a given amount of computing drops by half every 2 years. The growth in available computing power, however, has recently been accelerating beyond Moore's law. One reason is specialized processors, such as NVIDIA's graphical processing units. They do many calculations at once rather than one after another. Another is the availability of the most powerful computers for rent through cloud computing centers like Amazon Web Services. Those centers take advantage of the efficiency of scale to reduce the cost of building and maintaining a computer center. This recent acceleration in computing power growth will have a huge economic impact, similar to what a significant increase in oil production might produce today.
Everybody's talking about AI, of course. So tell us, how does that growth relate to artificial intelligence?
Well, today's AI is based on the technology of machine learning using deep neural networks, so-called deep learning. The technology describing these deep learning was fully developed in the 1980s, but computer power was too expensive to allow it to be fully exploited. The exponential growth in computing power over the years made it economically feasible fairly recently.
Amazing, amazing. So this was thought of way back when, but only now, because we have the computer power, are we seeing it come to its fruition and its infancy really right now. What are some of the applications of these neural networks?
Well, today, many articles on artificial intelligence seem to ignore the contributions of the technology to productivity and research in the past and assume the future is the very large neural networks, such as the large language models, or more broadly, generative AI, such as ChatGPT. However, neural networks have been used on smaller problems to great effect. Deep learning technology is a statistical technique that can summarize the implications of very large databases that a human could not even absorb in a lifetime. For example, neural nets have made speech recognition, talking to computers, very impressive today. Most people talk to their smartphones, digital assistants such as Apple Siri or Google Assistant. Many talk to Amazon's Alexa and a speaker at home. As someone who's done research on speech recognition, I am very impressed by the ability of today's technology. You can dictate to Microsoft Word and have it transcribe what you say just by clicking on a microphone icon.
Yeah.
Almost all radiologists dictate their reports to a computer while examining a screen image. Today, speech recognition is so easy to use that it doesn't seem to be treated as a triumph of AI, although it certainly allows a computer to do something that used to be unique human ability. That used to be the definition of AI. If you could do something that only humans used to do, and certainly speech recognition is one of those things. Other applications include self-driving cars, translation software, researching cancer cures, making production lines more efficient with robots, describing the folding of protein molecules, and many more cases. For example, a recent New York Times article concluded that Waymo's self-driving cars were involved in 91% fewer serious injury or death crashes and 80% fewer crashes causing any energy than cars driven by humans. The technology for specific applications is very powerful and is getting even more practical as computing costs drop.
Yeah, it's amazing. The first time I used ChatGPT a few years ago, completely blown away. We've gotten used to how good it is, so we take it for granted. But let's talk about large language models like ChatGPT. They've impressed us with their ability to generate articles on any subject with just a simple command. How does that work?
They use the largest neural networks to date and train them to guess words in an article using both the context of the article, the structure of the sentence, and the location of the paragraph within that article. Sometimes you read simplifying statements that they try to guess the next word, but they're guessing the next word by understanding what the context is and what the structure of an article is, with that's things like introduction, middle, and conclusion. Otherwise, they couldn't write an article. So just saying they guess the next word is a little misleading. By training them with a large amount of computing to get accurate at this, they created a model that could generate an article based on a few keywords in a request. Even the developers were surprised at how well the software could imitate a human writer when it first came out.
Yeah, it blew me away. Like I said, I had it craft an opening line of a novel with just a simple prompt. And I was like, I don't know if I can write this well. So it's pretty amazing. How do you view the performance of the current language models, the large language models?
Well, the current large language models are best used as an aid to a human by summarizing knowledge in a specific area that a human can check, remove, or expand. Because the models are statistical, summarizing the data they have analyzed that is related to the keywords in the request, they can sometimes deliver results that reflect misinformation or objectionable content in the data they have analyzed. They also can create information similar to data they have analyzed, but which is not factual, such as referencing patterns that don't exist. Such mistakes are often called hallucinations. This has led to companies using the technology in operations less than you might expect. The US Census Bureau recently reported that only around 10% of firms meaningfully use the technology. A recent study by consulting firm McKinsey concluded that for most organizations, the use of AI has not yet significantly affected enterprise-wide profits. The Economist magazine recently summarized in an article, quote, 3 years into the generative AI wave, demand for the technology looks surprisingly flimsy. MIT Technology Review titled a recent article on the subject, The Great AI Hype Correction of 2025. There is further wide discussion that providers of generative AI models will have difficulty in making profits that cover their high expenses.
Well, there are huge investments currently being made on computer centers to support much larger neural networks, with some of the companies even building nuclear power plants to provide power dedicated to the computer center. Their goal is sometimes stated as developing superintelligence that will exceed human intelligence. Do you think these large neural networks will deliver the expected results?
The short answer is no. I've gone on the record in my book and blog entries predicting the next generation of generative AI using the much larger neural networks will fail completely because of the lack of sufficient quality data needed to make the larger networks avoid creating nonsense. Nonsense will result from the huge number of parameters being optimized in the very large models overfitting the data, which gives too much weight to individual data entries. It's a basic problem with statistics. If you try to use a model where if you don't have enough data to the model, it's a little bit like taking a poll of two people, and if they agree, saying the whole world agrees just because two people agree. Obviously, you would say two people aren't enough for a poll. So that kind of thing of overfitting the data is an issue with any kind of statistics, and it's also an issue with these very large neural networks. I've said the larger models will generate artificial ignorance instead of artificial intelligence. Yet the investments to support ever larger computer centers continue. For example, Meta Chief Executive Mark Zuckerberg recently posted, quote, Meta is planning to build tens of gigawatts this decade and hundreds of gigawatts or even more over time. There's evidence this failure is already occurring. For example, the next generation of ChatGPT-5, advertises an update to ChatGPT-4 did not exhibit improved behavior to the extent that OpenAI CEO Sam Altman recently set off a, quote, code red, unquote, alert to employees to improve ChatGPT and to layer other product developments, according to the Wall Street Journal. A number of other companies have delayed announcing new versions, apparently because of problems with their behavior. Jan LeCun, chief scientist at Meta's AI lab, Meta is, of course, Facebook, and a professor at New York University, recently said, this idea that we're going to just scale up the current large language models and eventually human-level AI will emerge, I don't believe this at all, not for 1 second. So that's his quote. And recently, actually, I think he's starting a new company because he doesn't believe in these extra large language models being developed by Meta. The impending failure of these huge investments in the very large neural networks has huge implications for the profitability of the companies investing billions in the huge computing centers. And of course, all these huge investments in computing centers usually involve investments in electrical power plants to support them and even a water supply to cool them, making it even harder to make the large models a profitable business. Even if the larger models do improve results somewhat, there will be many companies competing to be your choice of generative AI, further reducing their ability to make a profit. The investments in very large neural networks will not create superintelligence.
That's a very strong statement, of course. So if the huge computer centers don't deliver superintelligence, what will be their use?
The computer centers built for generative AI are general purpose computer centers that could be used for other purposes. When it turns out they are not used for larger neural networks, the computing power will be sold to generate a return on the huge investments in the computing centers. The companies will become competitors for the highly profitable cloud computing services, such as Amazon Web Services. The competition will drive down prices, for advanced computing resources. Just as an increased supply of oil creates a drop in oil prices.
What can all that cheap computing power be used for? Will it allow for major innovations?
The cheap computing power will provide the fuel for innovative companies to introduce many new products and services at competitive prices. However, I believe the major impact on our use of digital systems will be the increased use of human language to interact with computers, a fundamental change in the way we interact with digital devices. Today, we can talk to Apple Siri and Google Assistant on our smartphones. We also use human language primarily by typing to the chatbots such as ChatGPT or Google Gemini. A major innovation is that all of these channels now support the option to talk or type, although most haven't publicized the option. They're increasingly attempting to continue a dialogue by giving you answers rather than just dropping you into a list of websites. You know, you've often said, Siri will say, well, here's what I found, and it didn't act like a web search. In fact, they use Google for their web search. The talk or type option is important because it makes the use of these digital assistants available in public environments where talking would be impolite or reveal private information, while retaining the efficiency of the speaking option otherwise. The increased computer power will allow the increased computer power will allow the digital assistants to be more like communicating with another human, and that they will be able to continue a conversation, remembering the context of the current conversation as well as previous interactions. Yeah. They will learn more about you in particular as you use them. New devices such as a reported wearable pin from Apple and smart glasses from Meta would seem to require speech interaction as a primary interface. The current digital assistants are already becoming an alternative to web search. We know how profitable that function can be by looking at Google's profits. Existing digital assistants, including Siri and Google Assistant, can also connect to other companies while continuing a conversation, although many users are unaware of that functionality and which companies support it. You could, for example, ask for your bank balance while talking to the digital assistant and then continue a conversation on another subject. The large language models are attempting to create similar capabilities through what they call agents. This makes them portals to the web in both providing information and interacting with particular websites.
Fascinating. Who will deliver and control these digital assistants?
Some of the large technology companies already have digital assistants they can build on. For example, Apple recently reported a change in executives and an increased focus on improving its digital assistant Siri. More generally, almost all the leading technology companies that are driving the stock market gains because of huge profits are also investing in the next generation of generative AI. I've argued they will end up with huge computing centers and seek to find uses for all that computer power they've invested in. Further, the improved talk or type digital assistants will become a major way consumers access the internet and the companies on it. The technology companies will compete to profit from this opportunity. If some smaller companies show talent in aspects of building these assistants, they are likely to be acquired by the larger companies for their talent and for their intellectual property. An interesting side effects of the control of internet access by these large technology companies with reputations to support is that they will be under pressure to avoid the assistants directly providing objectionable content such as pornography or hate speech, as well as avoiding simple misinformation as much as possible. The companies already hire many human monitors to avoid delivering objectionable content. The assistant models can learn to avoid such content automatically through feedback from that human review. Hopefully, this process will result in much less information and objectionable content being widely distributed through the internet and social networks as more people depend on their assistants for internet access. So that's a positive thing that could be a fundamental thing in with some of the conspiracy theory, avoiding some of the conspiracy theories and so forth that we see nowadays.
Yeah.
In an example of the effectiveness of a conversation rather than a web listing and engaging a user, separate scientific studies and published recently in the scientific journals Nature and Science found that a short interaction with a chatbot powered by AI could meaningfully shift some people's opinions about a political candidate or issue. One of the studies found that having a brief conversation with a trained chatbot proved about 4 times as persuasive as television ads from recent American presidential elections. The interactive nature of conversation can be persuasive in part by addressing specific issues important to the person in the conversation and for allowing follow-up questions for clarification. Conversation is very important. A financial driver is that a company could charge a premium for supporting an ad that used a conversation to sell a product or service, sort of like getting your own personal salesperson tuned to what you want and educated in answering any objections.
Amazing, amazing. We're out of time. We could talk to you all day about this because this is the future that is happening now and growing exponentially. As you say, some people are looking into the future. They see AI as a golden god. Others are not so optimistic about it. Wonderful topics explored within the pages of William's book. It is called Computing Power Drives the Future. It is a timely look at exponential computing growth and what it really means for society and the global economy. It's a fascinating work, and this has been a fascinating conversation today. William, thank you so much for joining me here today.
Thank you, Logan. I enjoyed it.
I enjoyed speaking with you as well. I appreciate your time, your insight, and the wonderful work you've done on this book. To the folks at home, I'm Logan Crawford, thanking you for your time this time. Until next time.